Hi guys, welcome to JIK 224 E-Kuliah series. I'm Dr. Sumia Sabah and this is the third video covering chapter 2, which is chiral example. So in this video, I'll give you more example on identifying a chiral structure. So upon completion of this topic, you should be able to recognize chiral structures, draw their mirror images, and identify features that may suggest chirality. So this is an example of a chiral molecule, which is a bromochlorofluoromethane. Okay, we have looked in the previous video that these molecules are non-superimposable image because the atoms, the mirror images of their atoms are not aligned to each other or not identical to each other. So this molecules is called a chiral molecule. So a chiral molecule is a molecule that is non-superimposable on its mirror image. So this is a chiral carbon, on the other hand, is a carbon atom bonded to 4 different groups. So let's look back at our model. So this is bromochlorofluoromethane. Okay, we have a carbon atom in the middle. So this is a chiral carbon or carbon chiral atom. So we have here fluorine, 1 group, bromine, 2 group, and chlorine, the 3rd group, and also the hydrogen. So now we have 4 different groups attached to a carbon. So this carbon is called chiral carbon. So a carbon bonded to 4 different groups is also known as asymmetric carbon or chirality center. And it is often we label this chiral carbon as asterisk or star. Okay, first example, locate each chirality center and draw both enantiomer. So for this example, you are given this molecular this formula. So what you have to do is that you have to redraw this structure in a 3D model so that you can identify where is the chirality center or the chiral carbon. So this is the 3D structure of the this formula. Okay, you have here CH3, CH2 here, and CH3. So this is the line structure. Okay, so you have to know that in each end here, in each of the end of the line structure here is a carbon, and that the hydrogen is not shown here. Okay, only for this one. Okay, so here we have 4 carbon in the main background. So the carbon chiral cannot be at the end of the structure. It must be in the middle. So we have 1 carbon here. That is, we have 1 CH3 group and 1 group attached to this. And then we have 2 hydrogen carbon attached to this, 2 hydrogen atom attached to this carbon. So this carbon cannot be the chirality center. So we focus on this carbon. This carbon is attached to a methyl group here and also ethyl group here. Okay, so CH2, CH3 is an ethyl group, and then we have the chlorine atom and also hydrogen atom. So this carbon is the chirality center or the chiral carbon. Okay, and then we have to draw its mirror image. So now we have a pair of enantiomer. Okay, because its mirror image here is non-superimposable to its first structure 1. Okay, so structure 1 and structure 2 is a pair of enantiomer. Okay, what about this structure? Again, you have to draw the 3D structure. You can either identify the chirality center at carbon number 2, 3 or 4. Carbon number 2, here we have 2 hydrogen attached to it, so it cannot be a chirality center. Similar to this carbon also, we have 2 hydrogen atom attached to this carbon, so it cannot be a chirality center. While on the other hand, this carbon it has 4 different groups attached to it. First, we have the ethyl group, CH2, CH3, and then we have the methanol groups, because we have here CH2 and also OH, and then here we have the alcohol group, the third group, and also hydrogen as the fourth group. So the chirality center is attached to this carbon, and we can draw its mirror image, which are a pair of enantiomer, because its mirror image is non-superimposable to its original molecule. Okay, what about this one? Now we have 4 carbon, including and plus this carboxylic acid, and also we have amine group here. So we can draw this its 3D structure. So again, these 2 carbon cannot be the chirality center, because these 2 carbon are attached to 2 hydrogen atom, while on the other hand, this carbon is attached to carboxylic acid and then propyl group. Okay, because we have here CH2, CH2, CH3, and then we have amine group and also a hydrogen group. So this is the chirality center. We can draw its mirror image, and we can see that its mirror image is non-superimposable to its original image. So we have here 2 pairs of enantiomer. Let's look at this example. Draw a 3D structure for each compound and star all asymmetric carbon atoms. Draw the mirror image for each structure and state whether you have drawn a pair of enantiomer or just the same molecule. So A, 1-bromo 2-methylbutane. So now you have to draw 1-bromo 2-methylbutane. So this is the structure of 1-bromo methylbutane. The carbon is attached to 4 different groups. So bromo, you have CH2Br, hydrogen, CH2, CH3, and also methyl groups. Now you have to draw its mirror image. And first you have to star the carbon chiral. So this is the carbon chiral, or the asymmetric carbon, because it is attached to 4 different groups. Now you have to draw its mirror image. So CH3 here is opposite to this, so you have to draw its mirror image, and from there you have to identify whether you have drawn an enantiomer or just the same molecules. So because it has a asymmetric carbon, so its mirror image must be an enantiomer. And then we have chlorocyclohexane. So this is a cyclic compound. So because we have hexane, so it's a 6-membered ring with chlorine attached to carbon number 1. So this could be the chirality center, okay, because we have here chlorine and also hydrogen, but you have to look at its ring, okay. This, when we go to the right, to the left, we see that actually this carbon and also this carbon are similar. So when we draw its mirror image, we can see that it is superimposable to each other. So there is no chirality center or asymmetric carbon. So this is we have no asymmetric carbon here. So this is same structure or identical compound. Okay, let's look at example number 3. For each of the following structure, label all asymmetric carbon atoms, draw its mirror image, state whether the structure is a pair of enantiomer or just the same molecule. Okay, now we are given this structure. We have to identify where is the asymmetric carbon atom. So this will be its asymmetric carbon, because only these carbon are attached to 4 different groups. Okay, so we can draw its mirror image, and we will see that this image is non-superimposable to each other. So they are called a pair of enantiomer. Okay, what about this structure? Okay, this is the bicyclic molecules. So try to identify its asymmetric carbon. From here, we can identify that there is 2 asymmetric carbon here. Okay, so we can draw its mirror image and try rotate, and you will see that it is non-superimposable. So this is a pair of enantiomer. Another example here, also this is a bicyclic molecule. You can try to identify its asymmetric carbon. Here I have identified 2 asymmetric carbon at these 2 carbon. You can see here, from here it is attached to different carbon, different groups. Here also is attached to different groups. So try to model, and you will see that both of these are actually attached to different group, 4 different groups. You draw its mirror image, and its mirror image will be non-superimposable to each other. So it is also an enantiomer, okay, a pair of enantiomer. So as a summary, chiral molecules have a carbon atom bonded to 4 different groups. This is known as chiral carbon. So all chiral molecules have non-superimposable mirror image. Every chiral molecule has an enantiomer. So this is the reference, and if you have any question, feel free to contact me at my email address, and thank you for listening.